Hi class. We have the fourth lesson for functions. Today we have a function like this: f of x equal to x squared. Because we have x squared. If it's like t, it will be t squared. If it is a squared. So something like that. If it's f of root 2, it would have been root 2 squared. So what is here depends on what we have in the function. That is why when normally or usually in functions we say let f of x equal to y, the reason we call y a dependent variable because what is here depends on what is here. All right. So this is what we are given as a function. But the a part is we are to find f of minus t. F of minus t. Come to think of this one. F of x is this. Now instead of f of x, it is f of minus t. It's so simple that f is maintained, even the brackets, parentheses here are maintained. But instead of x, it is now minus t. So you do the same. Go to the function. Wherever you see x, you write minus t. So for this x, what do we write? Minus t. We have a square. But note that x is not only replaced by t, but by minus t. Writing it this way is like the square is only affecting the t. And originally, the square is for x. So if the square is for x and x is replaced by minus t, the square has to affect minus t and not just t. So we have this one. Okay. So therefore, minus t squared will give us t squared, because the square is not only affecting the t, it's also affecting the minus t. Minus t squared is different from minus t squared like this. This one affects only the t, so only the t has the right to repeat. So this is minus t times t. Only t is repeating. Here, the square affects the minus and the t, so both are repeating. Minus t times minus t. Minus times minus is plus, t times t is t, so plus t is just t. This is how we got this one. Okay, so we are now going to the second one, f of half. F of half. Excuse me. Now, x is no longer to be replaced with what? Minus t, but now half. So in the original function, wherever we see x, what do we write? We write half. So for this x is half. We have a square, mind you. So 1 raised to any value is 1. So 1 raised to 2 is 1. 2 raised to 2 is 4. This is what we have. Now the next one is f of x minus 2. Yeah, you don't need to be panicked here. F of x, x squared. Now this bracket, this x, is now to be replaced with what? X minus 2. So wherever we see x, what do we write? X minus 2. So for this x, we say x minus 2. Don't be surprised, x is part of what is to replace x. Now this x is what? X minus 2, but there is a square. Yes. So even if you leave it this way, of course, it is correct. Yeah. Or you further expand, no problem. So if we further expand, we say x minus 2, then x minus 2. Remember, if you say 9 squared, we say 9 times 9. So a bracket squared is a bracket times a bracket. Only that when we are multiplying brackets, we don't necessarily need to write the multiplication sign between them. It is already understood that when brackets are written, two or more brackets, without written a sign between them, it means multiplication. So therefore, this will give us x squared um, minus 4x plus 4. Yes, so this is what we have for the A part of the question. So if you are interested in copying, pause the video, then you can copy. Now let's go for the B part of the question. So according to what we are given, if f of x equal to x squared before a comes, b comes. So it means even this function is the same one we are using for this. So f of x is x squared. So now we are at the b part of the question. The question says express as simply as possible f of a plus h minus f of a over h. All right, so we want to find f of a plus h minus f of a over h. Express as simply as possible. So we don't only do the substitution, the necessary substitution, but we have to simplify as much as possible. Okay, so remember f of x is this. So if x is now replaced like f of 2, so here, if you see x here, you write 2 instead. If it is f of p, you come to this, wherever you see x, you write p. If it is f of 2t, wherever you see x, you write 2t. So if this one is saying, if this one is saying f of a plus h, now x is now to be replaced with what? A plus h in this function. Remember, I used to tell you that this is just the label, but this is the function itself. It's like you are naming someone John. We have the name John and we have the very individual, the name and the individual himself. Yes, we have the name, let's say like Fatima. Yes, Fatima. Then we have the individual. So this is just the label. This is just the name. It could be just x squared. But what is the name of what is the label of the function? F of x. All right. So now this, instead of x, is now a plus h in this function. So for this x, what do we write? A plus h. Remember, there is a square minus f of a. We are given f of x, but now f of a. So instead of x, it's now a. We are in the function itself. So for this x, we say what? A, there is a square, over h. Don't think of doing the same for h to SQL, where there is x, write what? H, and say h square. No, we don't do that because this is not f of h. This one has f of something, and this is just h. So we cannot do what we did here or what we did here. Now this is what we have. If you expand this, now try to know how we expand when the power is 2. So we don't need to rewrite the bracket twice. Try to understand this one, please. Let me guide you how to do it. When you have two terms in an expression, we can say the expression is a binomial. And if the power is 2, let's see how we do it without rewriting the primitive way. So you take this one, you say a squared. Yes. So see what I'm doing now. 2 times a times h. 2 times a times h. So 2 times a is 2a times h is 2ah. We started with a squared and we must end with h squared. H squared. This is how we expand two terms with a square. Now let's say we have 2 plus 3x. Yes. So you say 2 squared is 4. Now you say 2 times 2 times 3x. 2 times 2 is 4. 4 times 3x is what? Is 12x. Then you must end with 3x squared, which is 9x squared. So we continue. So this bracket with a square has given us this one. Now we end with minus a squared. Remember, we have h here as a denominator. I hope it is understood. So in that case, you can see a squared minus a squared can go away. We are left with 2ah plus h squared over h. This would have been the final result. But the fact that The numerator has something common, h and h squared. When you have two different terms and there is something common between them, this h has a power of 1, this h has a power of 2. The one with the less power is common. So h squared is not common, but what? H is the one that is common. So the h that is common is taken outside. So the one that we've taken outside can take away this h, leaving 2a plus. And this h we've taken outside can take away 1h here. That will remain 1h, which is this, over h. So now this takes away this, leaving 2a plus h. As it says here, as simply as possible. So this is what we have for the fourth lesson. Thank you for watching. Don't forget to follow, like, share, and comment. Also subscribe to the YouTube channel.